Well guys, the F250, after draining the differential fluid and filling that up with some nice synthetic oil, has had its first maiden haul, actually. And this is the first time I've hauled anything with it, and I'll show you what it is I got. It's pretty neat. I was on the way home, just driving it around, testing it out, and passed by this house and found this lawnmower here that actually they were giving away for free, and I just couldn't believe it. I actually ended up driving by it because I didn't think it'd be a deal too good to be true, and I finally turned the thing around and talked to the guy that put it out there, and he literally put it out there in his front yard about maybe 15 minutes before I arrived. The engine was still hot. And this is just an unbelievable find, a lawn tractor like this for absolutely nothing except, you know, I had to haul it away. I just put it in the truck back in there and hauled it over here. And he said that the alternator in the engine wasn't charging the battery, and that the only way to get it to start is to jump start it. You know, you can either jump start it off of a car or this portable battery that I have here. And you know, I figured, you know, alternators in here don't really go bad all that much. There's actually a little stator underneath this flywheel, and the flywheel has permanent magnets around the perimeter that go past the stator and generates a voltage, just a single phase instead of a three-phase like a car alternator. They don't usually go bad, actually, so I'm suspecting it probably might be a little bit simple, and indeed it is. And I'll show you guys what I'm talking about. So we got a good charge on the battery. In fact, I'll turn my voltmeter on, and we'll go across the positive terminal. So we're reading 12.5 volts, which is good. And now we'll go ahead and turn the key on, and the first position runs the front headlights over there, and the second position is this position runs the headlights, and that position runs the engine. That starts. So we'll go to the first position, and you can see the voltage just goes down to almost nothing. And of course, if I go to start it, it just doesn't want to do anything, no matter what I do. So it's acting like the battery's dead, isn't it? That's exactly what a dead battery would do. Give you low voltage under a load, and then give you a relatively high voltage when there's no load. But if you look where I've got the test lead, it's actually on the terminal going to the battery, not the actual battery terminal itself. So if we take this off, and I'm going to probably need two hands to show this. Putting that terminal, or the test probe, on the actual battery itself, we'll get the same voltage, 12.5 volts. And you notice when I go to turn the key on, I have no headlights, but I still have 12.5 volts. And if I turn it to the run position, same thing, 12.5 volts. And now we'll go ahead and try to start it. 12.5 volts. So right away, that tells me the problem is located right here between the battery terminal and the connector that goes to the tractor itself, because that battery is fine. So to prove that, I'm going to try to bridge this connection here with my jumper cable, and I'm going to essentially jump it, but not really. I'm only going to hook up one cable to the battery. and let's see if she rolls over. I'll turn the key on to the headlight position. Now we have our headlights. We'll go to the run position, turns the headlights off, and we'll just jazz the starter a little bit, see if it works. And it does. So that's exactly what the problem is. We'll go ahead and take this back off now and see if that little bit of current to the starter motor acted to weld the terminal of the battery to the terminal of the tractor a little bit enough to get just a little bit more continuity, and we'll see what happens now that I took it back off. We have headlights, so it's going to work, or it might look like it'll work, but there's high resistance in here, and what cranking it over might have done is just make a little weld in there somewhere. Now if we go ahead and try to engage the solenoid and start this thing and try to pull about 100 amps through there, that weld's not going to be strong enough and it should not start. So we'll go ahead and try to start it. That's all it does. Now we're back to square one. Now if I turn the keys to the headlight position, we're totally dead. Nothing works. So I think this alternator is plenty fine. That explains why this thing always started when they jumped it, because they basically bridged this connection here, and because there's such high resistance in this contact, it also explains why the alternator in here was never charging the battery. So I can certainly see why they would have thought it was a bad alternator, but with just a little bit of simple basic troubleshooting, it took me about maybe 3 minutes to figure that out. I've got a perfectly good running lawnmower now. I'm going to go ahead and take that battery out and clean up the terminal. More than likely what ended up happening is they just used regular automotive chassis grease or something like that as an anti-corrosive and put too much on there and created a high resistance situation and therefore caused the problem. And because this is a fairly new battery, I bet anything that that's when the problem happened, is soon after this new battery was installed, which would further lead somebody down the garden path thinking, well, gee, I just put a brand new battery in here and it must be the alternator because this thing just doesn't want to start. But it starts when I jump it. So this is quite a bit of a find, and you know, I think what I actually might end up doing, it's such a good find that I'm going to go ahead and clean it up and get it working and everything, and then talk to that owner and see if he wants this thing back, because I've already got a lawn tractor over there, actually a much better model. I don't really need another lawn tractor sitting around. I don't really have much place to put it. I'm going to see if he wants this thing back. I kind of feel guilty taking it from him, but it was a lot of fun figuring out what that problem was. So hopefully this will help some of you guys. If you ever replace a battery in your tractor or your car or anything and you have a problem like this, check your terminals first. Move them around, take them off, clean them up, put them back on. You'll be surprised how much of a difference that'll make. But anyway, I'm going to go ahead and play with this thing and see if I can get it going again. Okay guys, now that I got the terminal all cleaned up and everything, it was actually able to be loosened just by hand. It wasn't even tight. And then I found out that the terminal on the starter solenoid was also loose, so that's all tightened up. I got the voltmeter hooked up to the battery, and now I'm going to go ahead and see if I can fire this thing off. And that'll do two things. It'll make sure it starts, and it'll also make sure the alternator is working. So instead of about 12.5 volts, we should have about 14.2, 14.5, something like that. So I'm not sure how to start this thing actually, because it's different than mine. Oh, I see, it's got a automatic choke. And let's see what happens here. I'm gonna watch that voltage drop. Okay, we have lightage, and now we'll crank it over. The alternator actually might be bad because I don't see the voltage going up to 14 volts. So there might actually be two problems with this thing. That does warrant further investigation, that's for sure. Maybe those terminals were loose because they were trying to troubleshoot the alternator. Well, at least I know the engine runs pretty good. I'll troubleshoot that when it's a little bit lighter outside. It's getting kind of late now, and see what we come up with. Well guys, I went to night shot mode for the first time because I can't leave well enough alone. I'm like a bulldog when I see problems like this. I kind of get excited and want to see what the answer is, and I think I might have finally figured it out. It's related to the alternator, but it's not the actual alternator. Coming off of the stator, you got two white wires, but I got broken out right there, and that's the AC voltage coming off of the stator under here, and that's running around 35 volts AC. And I've got that broken out so I can go ahead and connect that to the input of this voltage regulator module right here, which regulates the voltage and contains a diode trio to convert it from AC to DC and also step down the voltage. And I should be getting 12 volts right there. And when I put my meter on there, you can't see, but it's not registering anything. So I'm fairly confident that I can go ahead and put a little bit of money into this thing, replace that regulator. I haven't worked on never worked on Kohler engines before, but it seems like a pretty nice motor. It's able to run like this really slow, not burning any oil or anything. Just a little single cylinder. Hopefully that part's not too expensive. I can go ahead and replace it, get that battery charged up, get it running right, and then see if I can either keep this thing or talk to the owner, tell the owner what it is I did, and see if he'd like to have it back. He gave it away for free, but it's just too much machine really to be just given away for free, especially what kind of condition it's in. It looks like it's brand new. So I'm going to go ahead and try to source this part someplace, and then show you guys the result. While I'm back, still troubleshooting this, and I had one more idea, and that is to see if I have enough current coming off of the stator and that alternator to drive a load. So even just because I had about 24 volts or 35 volts depending upon the engine speed coming off that stator doesn't necessarily mean that it's got enough current carrying ability to do any good. You know, it could be a burned up wiring or high resistance in the wiring. So before I waste any money on a new voltage regulator module, I've got a 24 volt lamp. I can't shine it right in a camera, it's too bright. It came out of a card reading machine from the old days, computer card reading machine. And as you can see, I had to turn the engine down as low as it'll go to get about 24, 26 volts across this thing. I didn't want to burn the light out. But that alternator clearly has enough current carrying ability to run this 50 watt 24 volt light with ease. So I now have confidence I can go ahead and replace that module in there and get this thing fixed. So the next shot will be replacing that and see if I actually have 12 volts going into the battery up there. Well, now I got the voltage regulator pulled out of the mower, and this is where the ground was attached, and you can see how eaten up that was due to all the arcing over the years. So that makes me wonder if I have just a connection problem here on the regulator for the ground, or if the regulator is actually bad. So before I go spending money on this thing, I think it's about 30 bucks, I want to go ahead and test this. And the way it works is you've got AC input on both of these sides from the stator of the alternator, and you got your B plus here and your ground. So basically what this thing does is it rectifies the voltage and also steps it down from anywhere between 24 volts to 35 volts down to 14.2 volts. So all I really have to do to test this is just apply an AC voltage here of about maybe, somewhere in that range, 25 to 35 volts. And I think I've got just the thing for that. I've got this extremely powerful 220 volt primary transformer. It's running 12.6 volts center tapped, about 25 volts across the whole transformer at about maybe 200 amps. And then of course we have a 220 volt primary, and that's actually not the biggest transformer I have. So let me go ahead and fire that thing up, and we'll be able to apply voltage to the regulator and see what happens here. I got it hooked up to the 220 volt outlet for the generator receptacle that I made earlier this year. And just be careful if you do something like that. That's like a suicide plug, so if you get your hand on it or something, you'll get a big surprise. But this is just for temporary testing purposes. So we'll fire this thing up and see what happens here. And you can hear that bad boy running. That's got some serious current coming out of there if I wanted to. I could start a car with this all day long. But I really just want to use it as a voltage source, so we'll go ahead and hook up our regulator. And I got the voltmeter on AC volts. This is going to be tricky to do by hand. Let me unscrew these. Let me put the camera down and hook this up. Wish I had more than one hand to do this. So we've got 25 volts AC going into the voltage regulator, which is about what I had last night coming off the stator of the alternator powering that light. And we'll go ahead and switch over to DC and measure the output between here, and I should have about 14.2 volts. And I don't have much of anything. So that tells me right away that this voltage regulator is definitely bad, and I've got full confidence that I can go ahead and put money into this and replace it, because I know that the alternator on the lawnmower is good as well. So I'm fairly confident this is the source of the problem. And what I'll do next is go ahead and source that part and see if that'll fix the overall issue. Plus it gave me a good excuse to get this old thing running again. Okay, now I finally sourced a brand new part, a genuine Kohler regulator rectifier to replace the old model. And it looks like we have significant burn marks here, indicating that there might be a problem with the connector on the lawnmower. But what I want to do, like always, I want to test the new component first with an AC input source, just like what would happen with the alternator on the lawnmower, and see if I have 12 volts coming off the regulator. So let me hook this thing all up and see what we get. Well guys, I got interesting news, good news and bad news. Here's the new regulator, and there's the old regulator. It turns out that the way I was testing it wasn't really the best way to test it. I get 0 volts or near 0 volts on the output of the new regulator, just like I had on the old regulator. And it occurred to me that maybe this regulator is designed in such a way that it needs somewhat of a load on here in order to start outputting a voltage. So I have this starting battery hooked up to basically simulate the entire charging system of the lawnmower. I've got this transformer acting as the alternator, going into the regulator, charging the battery, and a voltmeter to let me know what happens. So I've got 13 volts on the battery right now, and I got the battery hooked up to the regulator, and I'm going to go ahead and connect the other lead of the quote-unquote stator to the regulator, and you should hear the transformer change pitch to it a little bit. Sure enough, we have 14.2, 14.4 volts. So this regulator is good. My initial hunch that this area of the regulator was so burned up that that might be the problem actually turned out to be correct. I did not test this thing properly. Now if I disconnect the battery from here, and then I measure the voltage coming off of B+, I've got nothing. So it looks like the regulator's bad. But that's not really the case. If I go ahead and hook everything back up, I get 14.2 volts, 14 volts. And if I go ahead and simulate turning the engine off, we fall back down to 13 volts. So this regulator is in fact good. The place I bought the new regulator from won't take returns, so I guess I've got a good spare regulator with a nice surface for connections. And if I check out where that wire was mounted on the lawnmower itself, we can see that we definitely have problems, and that was the problem all along. I didn't have to spend any money on this lawnmower, but when in fact I actually did. Here's the ground connection, completely eaten up with continuous arcing. So I think if I clean this up, and if I can't clean it up, if I put a new connector on there and then clean up that regulator, I'll be good to go. So I think I've proven all that with my little setup over here. I'm going to go ahead and clean that up and then try to fire up that lawnmower and see if it's fixed. Okay, I've got the regulator installed and the engine running, and I got the headlights on to create the most load I can. I still have 12.25 volts, so we're not charging. And it turns out that that connection right here is so bad, I'm going to probably have to run me another wire and new connectors, quick connectors to the other side, or use a new connector and then go ahead and use the new regulator. But just by moving that around, you can see the sparks. So this has been sitting there doing that for God knows how long, and that's what made all that, those marks on the regulator and ate into the metal. There's an easy way to fix that. If I move this around even more, there we go. I can get a good charge going now, 12.6. I gotta keep pressure on it. If I don't get a charge. So I think that size had it. I think this side of the regulators had it, and part of the problem is, I think it's a design flaw, is this fan shroud here is plastic, and when I went to tighten in this screw, to a lesser extent this other screw, it started to get real soft on me. You can't really apply a lot of torque on these screws into this plastic housing. That's a design flaw that's not going to be easy to fix. You want to have the regulator in the housing to take advantage of the fan. This guy's got to be kept pretty cool. So I could easily make a longer wire and go to the other side of this and get more life out of it, but the root of the problem is these guys can't have that much torque applied to them, so that's as tight as this thing gets. Look how loose that is. You can already see it's starting to eat into the aluminum, and as it eats into the aluminum it gets looser and looser because there's less material to hold that screw on. So it's kind of like a runaway process. I mean, in fact, it's so loose I can back it out by hand almost. It gets more loose, so it gets starts to arc more, and as it arcs more it eats into the material and it gets even looser until finally you have no connection at all. So I'm going to think about that for a while and see what kind of solution I can come up with so this never happens again. I wish I hadn't bought a new regulator. That part was around $77 for a genuine Kohler part, which I like to have. I know they have generic ones for about 30 bucks on eBay, but I wanted to have a generic part instead of something, I wanted to have a genuine Kohler part instead of something made in China or something like that to last me a long time. But I've either got that as a spare or I've got that as another option. I could just put the new one in there and put a new connector on and go from there. But I'll continue the video once I come up with a good game plan here. Okay, well that didn't go as planned, so I've got the old regulator taken back out again. And I may have showed you guys before, but here's the ground connector for it. And there's the business side of it, and you can just see how eaten up that is even after I cleaned it, and you can sort of see the new area where it was arcing right there on the edge. And the main reason is that regulator is held in there to this plastic shroud, and you just don't have a lot of meat there for the screw to grab onto, and you can't apply enough torque on that screw to hold it down and press this against the body of the regulator to make really good contact. And because of that and the vibration of the single cylinder engine, it just worked loose. So I'm going to go ahead and use the new regulator anyway, because the old one has a pretty bad burned area on that side of it. And to keep this from happening again, I'm going to see if I can make some improvements to this. I think this is basically a design flaw. This fan shroud really should be made out of metal, something a little bit more substantial. You know, maybe made out of metal with some thicker sections here and here to tighten the screws down or bolts down even harder. So I'm going to try to take this thing off and went to Home Depot and bought a lot of hardware for it. I'm going to try to use these bolts here along with these star washers to really dig into the soft aluminum body of the regulator. You can see here how burned up that is even after I tried to clean it. Here's the new area here where it started to arc in a new spot. I think these kinds of star washers here will really be a much better arrangement to bite into this material and provide a much better ground. And I'm going to go ahead and use a combination of the flat washers, the star washers, and of course the nut and bolt. And of course the new regulator, which is a genuine Kohler regulator. Paid a little bit more for that, but I think it'll be worth it. And I'm also going to make some improvements electrically. I'm going to go ahead and dispose of this eaten up crimp connector right here and pop a new crimp connector on there and keep this engine ground where it is. But I'm also going to take, and by the way, this is 12 gauge. I'm also going to take some thicker 10 gauge wire and some crimp connectors, a little bit larger crimp connectors. And I'm going to run a secondary ground wire from the regulator directly to the battery terminal, kind of like they've done already for the positive that side of the alternator, directly to the battery. And I'm just kind of using my experience that I have for cars. This is kind of the same way. Most cars have a engine ground as well as a body ground, and I'm going to go ahead and try to do that here in this case. So let me go ahead and get this cover off of here. And I never really worked on a Kohler engine before, but it seems like a pretty nice engine. Kohler Command 17.5. Nice engine, except for this minor design flaw here, but I think I can easily address that. And we'll see how that goes here in just a second. Okay, I've got the new regulator mounted, and I decided to go ahead and fab up a new connector to replace the original connector with the corroded terminal. And hopefully you guys can see the difference in wire sizes. So what I ran in there is a 10 gauge to replace the 12 gauge. And so that's going to go to the engine ground. And I got the other ground wire that's going to attach directly to the battery. And I've got the cover all cleaned up and everything. Just took the opportunity to do that. And then you can kind of see the lock washer arrangement where that star washer is kind of digging into the metal of the regulator. Then you got the crimp connector, then you got another washer, and then a bolt. So that's going to make very good contact. And we got the same thing on the other side. And then to hold this regulator in more securely, we had the same arrangement, except the star washers are serving to kind of dig into the plastic a little bit to keep the nut from backing off and getting into the flywheel and everything and causing a bit of a mess there. But I'm able to apply a lot more torque on these fasteners here, much more than just running a plastic, bolt through there that's just geared for plastic. You can see this plastic is not very thick. There's not much to grab onto. And there's the part number of the new regulator. So now this thing's ready to be assembled now that it's all prepped up. And the only drawback to this arrangement is that if you wanted to replace the regulator, you have to remember to take the shroud off now, so you can gain access to the bolts, the nuts behind there. But small price to pay for reliability. And since this is a genuine Kohler part, there really shouldn't be any issues. So I'm going to go ahead and put this thing back together and see if this will finally cure my problem. Okay, the new voltage regulator is in. That's what it looks like. I did have one casualty down here. That fastener was in there so tight I just twisted the head right off of it. So I'm going to have to drill that out and buy a new fastener and fix that. But I got the new ground wire put in originally where it went. Used a larger size crimp connector to get more surface area around that fastener. And then I also have the ground wire directly attached to the battery, and I made use of the existing cable guide here to kind of tie that back up nice and neat, so it kind of has an original look to it. And now we're ready to start this thing up for the first time. I've got the voltmeter on here, and battery is a little bit low from before, and it's this alternator is actually a 15 amp alternator. It's not all that powerful, and this is a pretty decent battery. It's got 300 cold cranking amps versus the one of my other mowers there. It's got only 150. And so that battery could easily take a lot of current out of this thing. So I might not really get 14.2 volts once I start it up. Might be around 13 something, but we'll see if all this work has paid off. So we'll go ahead and throttle it up and set the choke. And we'll turn the key on to the first position, which would be the lights. And see what the battery says now. Yeah, it's running on down there. So we'll go ahead and try to crank it over. And we'll see what happens. Going to about 13.6 volts. And it's getting way on up there, which is good. So I call that a successful repair. Let me slow the engine down a little bit. And of course, we're not going to get the same voltage with the engine running that slow, but that's definitely fixed. Nice, steady 14 volts charging that battery. Let's see what happens when we turn the headlights on. Running really strong. Still got 14.2 volts basically. Headlights are nice and bright. So I hope this is helpful to anybody that has the John Deere L110 tractors with the Kohler engines. I wouldn't be surprised if that's a common failure. Due to the plastic shroud around the engine and everything. And just kind of wanted to share that with you guys and maybe give you an idea of what you can do to repair the design flaw in there using standard components that I found at Home Depot. And if you ever have this problem where your alternator doesn't seem to be charging the battery, instead of replacing the battery or replacing the alternator, look at the connections to the regulator first and see if you didn't have the same problem that I did. You might get lucky and your regulator is not as burned up as mine was. You might just be able to use the existing regulator and just bolt it down more securely like I did here, not really spend much money at all. But this lawnmower was actually free. I'm thinking about just going ahead and giving it back to the guy because this doesn't really take a whole lot of effort and money to fix. But the regulator was around $77, and the wiring and the quick connectors and stuff probably around $15. So, you know, roughly $100 everything for a lawnmower is a nice riding lawnmower. The 42-inch deck is not bad at all. So, hopefully this is helpful to you guys when you work on your lawnmower.